Okay, so building off of what we just did with similar triangles, we're going to talk about the application of it. So anytime you see the word application, typically it's going to mean real world or life examples. Okay, so anytime you see application, that's more or less what we're referring to. Okay, is we're just trying to take a lot of time in math, you'll see a bunch of letters or a bunch of shapes or a bunch of numbers, and we just go and do it without really thinking about how it applies to the real world. So whenever we see application of something, that's typically what we're getting at. All right. So our instructions here are to introduce the unknown measurement with a let x be statement. And if you've never used this before, it might be a little refresher, but whatever we're trying to find, we're going to put it as x in our equation. And we're going to, something we do in math and we do it in science, is anytime we're going to put in a variable to be an unknown, we usually say let, and then whatever we use, be, say, the unknown side or the height of something or whatever it is. So you'll get a better understanding when we go through this first example, but we need what's called a let x be statement, or a let statement is really what we need. And then we need to write a concluding statement, which you've probably seen these before, those three dots. Do you know what those mean? Therefore, right? So therefore, we conclude this and this, right? And then we round off our answers to one decimal place, okay? So when we're doing this, we're going to do one decimal place, and we make sure we include our units of measure, whether that's centimeters, meters, miles, kilometers, inches, whatever it asks you on the board to do, just make sure that you're doing it throughout, okay? So I'm just going to zoom in a little bit here just to make this picture a little bit better. So it says the example is a meter stick, which is this right here on the left-hand side. Okay, that meter stick is like I grabbed a meter stick and I put it into the ground. Okay, it's a meter tall. I just put it into the ground. That's what it is. And it casts, or sorry, it says a meter stick and a flagpole, which is right here, cast a shadow. So like if I was standing up on a sunny day, you'd see my shadow. Same thing if I had a meter stick in the ground, you'd see a skinny little shadow, or a flagpole, you'd see the shadow on the ground, okay? So it casts a shadow, and the measures of the shadows are shown. So that's these measures on the bottom here, okay? So the 1.5 and the 9.75 are the shadows. So the meter stick shadow is 1.5 meters long, and the flagpole shadow is 9.75 meters long. And it says, how tall is the flagpole? So basically, we can use triangles, right? These are just basically triangles if we want to think about it. Or we can just think, well, the ratio is shadow to object is 1.5 to 1. Or if I set up, it would be 1.5 over 1, or it could be 1 over 1.5, regardless of what it is. But we know we need to find the height of the flagpole. And in this case, we're going to mark it as x. Okay, so put an x on your diagram. And our job now is to say, let x be, and we're trying, whatever we try to find, that's what that's what x is. So in this case, let x be the height of the flagpole. Okay, so you following me so far? We know that the meter sticks in the ground, the flagpole's in the ground, and they both have shadows. The shadows, we know what they are, but we need to set up a ratio. So just like we did with our triangles, I kind of just drew us some triangles there. We have x right here. We've got two similar triangles because they both have a right angle. So if I put, let's just say the height of the object over shadow, I would get on this one 1.00 over 1.5. Fair? And then what would the equivalent ratio be? Yeah. X over 9.75. Following me there? Making sense so far? Cool. And we know that it's in meters. So at the end of the day, we're going to have to make sure we include meters at the end, okay? So now we've set up equal ratio. So what do we do next? Awesome. So we're going to do cross multiplication. So then it would be 1.00 times 9.75 is equal to 1.5 times x. And if we did 9.75 times 1, it's just itself, would be equal to 1.5x. And how do we get x by itself? Divide both sides by 1.5. Awesome. So then x would be equal to 6.5 is what we got. So 6.5, and then what's our measure? Meters. And then what's the last thing we're forgetting? Yeah, the therefore. So therefore, what do you think we could write? Okay, close. What's x? Perfect. So we put the height of the flagpole. And that would be a proper therefore statement. Right? So you're not wrong by saying the height of the or the x is 6.5. You're not wrong by saying that, but remember we let x be the height of the flagpole. So let's go back and have a proper sentence with that.